Yeah. Hi, smiling evening to all the CoderRange community members. Hi to everyone. So who have joined this CoderRange meetup on DSA. Today I'm going to talk about the most important aspect of DSA, that if you progress or if you can process or follow up this uh, way, you're going to successfully solve a real world problems of any kind of complex data structure problems and use cases. This course or this program has been bundled as series, and this is the first series we are going to take up this program. So here what we are going to do action plan is we're going to do the action plan like this. So we're going to first talk about so that is our goal is to make you understand on. Firstly, we will help you to understand two important aspects. One is we're going to talk about the memory fundamentals. That is, how is the memory? What is it we're going to do? How we're going to talk about all those aspects. That is first memory fundamentals. So then we're going to talk about the internals of your all the memory fundamentals. After that, we're going to discuss with how exactly the sorting, searching algorithms is going to work. And then we're going to discuss the top 5 patterns. And then I'm going to give some cheat codes throughout this thing. And then we're going to make you understand how this all patterns are going to work. Okay. So let me start with first memory fundamentals. So this program is completely going to be on Python itself. So I hope everybody is comfortable with Python. So we're going to do with on Python specific examples. Okay. So when I talk about memory fundamentals, so first we will give an example of, first we will take here the memory, that is we're going to talk about memory here. So whenever you're going to solve real world problems using the any kind of concepts in Python, so first we have to deal with memory. So in this memory, I'm going to talk about what exactly. I will do a brief fundamentals and then I'm going to talk about real-time advanced use cases. So let's talk about this detailed. So first, when I'm talking here about memory in Python, everyone knows we can create a list and we can do any of the data structures. So let me first create a list here. Okay, and this list will have some set of values 1, 2, 3, 4, 5. Correct. Now, if we talk about this list, so as all of us, we have to know two important aspects, guys. Whenever we are working with DSA, so what we have to know is how to access this memory. So the first thing is we all know to access this memory, we will be using. Suppose if you see this list, every memory has got index. So if you have this data, apple, banana, cherry, date, so this data will have an index. So what is an index? So if you see this list also, I would have the index 0, 1, 2, 3, 4. I mean, if you go with the reverse direction, you will have index -1, -2, -3, -4, -5. So we need to understand these indexes first. Okay. Now, if we can do this with a simple DSA and any of the real-time scenarios, why these indexes matters a lot, I will also talk about that in depth here. So before I talk about that in depth here, in list, so whenever we are doing any kind of use cases, that is indexes can be 0, 1, 2, 3, 4, and indexes are like this. So now let's take an example. This is my list. Okay. If I have this list, so purposefully in this list, I can grow data. If you want to access, I can do a memory accessing. Let me do a memory accessing here. So we will have first fundamentals for some of the people who want to really understand fundamentals. So I will try to access fourth index. So 0, 1, 2, 3, 4. That would give me 5. Okay. So that would give me 5 here. Okay. So now that is working. Now what I would try to help you to understand here is to carefully understand this concept here. So for instance, any memory if you want to access, there are two ways in Python. Remember carefully. If you have a list here, what is this list actually? What is list actually doing here? So that is something we have to understand. The memory accessing in this aspect of it. I'm trying to tell you in the memory accessing. This list can be accessed in two ways. Listen carefully. One is with index, the other one is with value. For an instance, let me tell, I'll write for I in list. So what will in do? So in this case of in, it is going to get me the value of the list. It is going to get me the value from the index. So carefully listen. This is how it's going to get your value from the index. So that means you are going to get a value from the specific index. So it's going to get each value from this index. Maybe from 0th index, it's going to get you value from the index 1, next time 2, next time 3. In is going to get value from the index. So let me print here smile, comma I. Okay, and run through this code. So you will get an index value from this indexes. But suppose we want to access it, we can access the same value with here indexes is there, but indexes is directly getting the value from this. That is what happening. Now I will demonstrate one more important memory accessing. This is something important for a developer. Now let's take this is a list. This has 5 elements here. And in this list, we can take two important concepts. So first important concept is carefully listen. I would try to add this list in a specifically, let's say, we will try to have for I in range of. So let me give you an index. This is an index I'm trying to specify here. So let me give an index that's I start from 0. And what's the value I have here? So maybe I'll specify 3, 5, right? So I'll specify 0 to 4. Okay, and print here smiles. And I will try to access here with, if you specify here smiles 1, and I'll try to access here I will only give me index here in this case. So I will get the indexes only here, not the values. Now, if I want to get the value from the indexes, I need to pass this indexes in the list. So I have to specify here list. Inside this, you have to specify this indexes. Okay, you have to specify these indexes. Now you may be getting this question, why do I really need to know this, Venkatesh? Yes, if you are to perform any kind of searching, sorting, the logics, a person should know first how to do memory accessing. That can be with index or value. That is something he has to basically understand. Coming to the next point that every coder here wants to do is that Venkatesh, once you know memory fundamentals, this is a list, apple, banana, this is a list. So I have indexes and we know the indexes, but how to access this indexes? So a person has to know how to do memory accessing very detailed. It means if you write 1:1, it means what? It starts from 1 and it ends that index also at 1. So it means now if I start saying that there's no element between that will come there. If I write this kind of indexing is very important. We have to know detailed whenever you want to write any kind of logic in your real-time scenarios. Okay, so now let me demonstrate that. That means if you write :-1 means it starts from the last index, from start till the last index, exclusive of that. From start till last index -1, it'll get you the value. That is A, B, C, D. So this accessing are very important. So let me do one indexing like this. Okay, so let me give here, let me write down the list. Okay, and then you will be able to access this. So you can straight away see this. It's going to give you this from this one. So this kind of accessing are very, very important for a basic developer. So now I'm going to start with fundamentals only. But remember, people who are going to stay for a long time, you're going to take a great formula. But that is something amazing. That is something you're going to use it. Instead of solving so many lead codes, I have a supreme formula. You can use it for your real-time day-to-day use cases. So I can use this way also. A :1 means what? I'll get access from the index 0 and 1. That is A and B. If you want, you can access that also. Now, why I'm doing this is because someone who was a beginner level, so he has to do this understanding it, because he need to understand or practice this accessing it. So you can access it at this index 1. Okay, so this is how you can start and access the first index value, that is index 01. Okay, now memory accessing is done, so you can access with all this memory accessing. That is superb. Now we all understood. Now someone in the audience here commented, let me ask you this question. Someone who commented me saying that, so many coders are there here. Let me ask you this question. See, so most of you who have done lead code problems, let me ask you this question. Guys, are you really very great at searching sorting? And do you use searching sorting in all your lead code problems? Anyone commented? Do you use a lot of searching sorting techniques in your lead code problems? Are searching sorting techniques or the advanced layers of patterns? Can anyone comment in a chat box, or you can unmute and also speak, guys? Any comments here? Anyone who wants to answer? We have
Yes, absolutely.
Kritik.
Hi.
Yeah, you can tell your opinion, no problem.
So in probably when we are doing sorting, say probably
Sorry?
I'm currently working on LLMs. So we have too many of tokenizations. Okay,
Okay.
tokenization of transcripts and where we are working probably. So
Okay.
often it happens that we have to work with sorting of transcripts,
Okay.
probably the statements or the names what are coming up. So in
Okay.
that way, probably we can use alphabet sortings, stuff like that.
Okay.
So probably we do have the way of probably a linear search or probably
Mhm.
finding up a particular word in sorts that
Correct.
way. Yeah.
Yeah. Thanks for that. So let me tell you the real-time use cases, what I'm trying to say. In lead code, maximum problems that you're gonna incorporate in understanding will be using searching as well as most of the sorting techniques. So that's been used here. So if anyone who wants to understand the fundamentals of lead code problems, that coder has to know searching techniques as well as sorting techniques, because we use both of the combination according to the problem. So if you are solving 70 to 80%, let me tell you this. This is a secret that, because I have solved many problems, 70 to 80% of your lead code problems are basically helping you to 80% of the lead code problem. You have to master searching and sorting. Now, let me see how many of you can comment here. I can, yeah, I think someone who is, please. Can anyone tell me which sorting techniques or searching techniques are we using widely in lead code problems? Anyone here who wants to add your point? No, linear, no. But let's see which sorting and searching are widely used.
Can you help to mute somebody's mic is left open?
Yeah, that's why I'm just asking them to. I've muted them, right? Okay. Yeah. So can anyone help me here? Someone who can help me? Binary sets. Okay. If you have solving, let's say 400 lead code problems. Okay, let's take you take we are solving 400 lead code problems, and which are majorly used. Okay, someone I can see there, binary sets. Okay, so can anyone other gives any other answer? Majorly. Around, you can see that typically, let me give you an answer. You will see someone in the lead code, I appreciate them. Binary sets, yes. You would see binary sets as one of the major technique that we are going to use it in your real time. Second thing is your for your tree graph traversals, you will use search also, binary search on most of the other cases, and you will be using some back tracing searches also. So almost most of the real-time lead code problems are based on, I can say that 700 plus problems are based on binary search. It's completely that kind of depth you have to know basically on that. So I'm going to continue this. I'm going to continue this. I'm going to help you guys to understand that as well. But give me 1 second, guys. I'll just charge it 1 second.